Hey chemistry, welcome back to the lab. So here we are getting ready to do our very last lab of the year. So we've been talking about mole ratios and how you can use them in chemical reactions. Yesterday you did a little pre-lab about hydrates. Today we're going to do the hydrate lab. The hydrate we're looking at is copper sulfate. So let's get going. So make sure you have your lab sheet or your lab document open and ready to go. So we're going to be looking at hydrates. So our hydrate of choice today is copper sulfate. It's a blue crystal. We might have used it before in class. It's a very common chemical to use. So a hydrate is actually a solid that has water connected to its crystal structure, and we can just easily remove the water by heating it. So we're going to be using a Bunsen burner today to heat the water away from our hydrated crystal. And when we heat that away, the water will just go into the surroundings and we'll have what's called an anhydrous crystal left over at the end. Okay, so for the lab we are going to be using a crucible. This is a crucible. I think we've seen them before. You can heat them to very high temperatures and they do not break, which is good. So we have to, first thing we have to do is find the mass of our empty crucible. Okay, so let's record that. So our empty crucible, 24.55 grams. Okay, and then it says measure or add between 3 and 5 grams of the hydrated copper to sulfate. Okay, so this is what the hydrated copper sulfate looks like. So we need between 3 and 5 grams. So So end up with 29.21. And all you'll have to do is subtract those two data points to get your mass of your hydrate. Okay, so the next step in our directions say to heat our crucible using a Bunsen burner. So we're going to light our Bunsen burner here. Okay. Make sure we adjust it so that it's got a nice small blue cone. That'll be the best flame for us here. Okay, we're going to put our crucible in a wire triangle here so that it is be over the Bunsen burner, and we'll just put the Bunsen burner there. Turn that up just a little. Okay, and then we're going to let that heat. Alright, so now we're done heating. You see that the crystals have all turned white. We're going to let them cool a little bit and then we will finish taking our measurements. Cooled. So the last step that we have to do for the lab is figure out the mass of anhydrous that's left behind. The anhydrous crystals are white. Okay, they don't have the water attached to them anymore. This is cool enough I can touch. Okay, put that on our scale. And the mass of anhydrous is 27.54. So when you go to fill out your data table, you should have these values all in there. Your empty crucible, crucible with your hydrate, mass of your hydrate, mass of your crucible with anhydrous. So how are we going to figure out the mass of just the anhydrous? Oops. So if we know the crucible and the anhydrous, we want to know just the anhydrous. Subtract out your empty crucible, right? So you're going to take 27.54 minus your 24.55 and you get 2.99 grams. Okay, so your hydrate was 4.6, your anhydrous is 2.99. Why did it get smaller when you heated it? What caused that difference? It's water. So we could pretty easily calculate the mass of water. We would go 4.66 minus your 2.99. And you would find that we actually evaporated 1.67 grams of water. Okay, you'll need that for calculations in later parts of the lab. So just want to go over a couple of little things on the next page for you, the analysis. The first question is the chemical formula for copper 2 sulfate. So if we go here and we're saying that we have copper 2 sulfate. All right, this is just another example of a time copper, where you need to use your charges to write your formula. So copper 2 would be Cu2 plus. Sulfate, if you look on the back of your periodic table, SO4 2 minus. A 2 plus and a 2 minus would just cancel out. So copper 2 sulfate anhydrous is CuSO4. Now, that's the anhydrous. Anhydrous means without water, okay? The prefix "an" means without. So that is without water. When you have water attached to it, you are going to figure out how many moles of water actually attaches to it. That is the whole point of the lab. So as you work your way through your calculations, you're going to figure that out. I have them in order to help you solve that. So hope that was great. It's been a great year, great lab, great last lab. Bye guys. Psych, I know I said that we were done. But one last thing I want to show you. It's really easy to rehydrate the crystals. All you have to do is add a little bit of water. Ooh. And the water will just attach right back onto those crystals. It's very exothermic, giving off energy, because actually the hydrated form is the preferred form for them. So when they get their water back, they're very happy, so they give off a bunch of energy. Okay, now we're actually done. Thanks, guys.